Hi, for this video we're answering a question from one of my students on the Telegram group, AskPercy. So you can also go to the Telegram and search for a group called AskPercy, and then you can post a question that you're struggling with, and then I'll quickly create a video that shows you how to answer that question. So this is one of the questions that I got, so let's go. So this is how the question look like. This looks like a trigonometry question. So basically here we are asked the first question, 5.1. Simplify each of the following without the use of a calculator. Okay, and show all your calculations. So this is one of the common questions that you will get in trigonometry, right? So sine 110 degrees. So you're given sine 110 degrees tan 60 degrees over cos 540 degrees times tan 250 degrees times sine 380 degrees. Okay, so before we go any further, a couple of things that you need to know. Number one, you need to know that remember you are being specifically told don't use a calculator. So you need to know that the sum of the angles within a triangle, they all equal to 90 degrees. Now if you have a right angle triangle, so meaning that you have a 90 degrees, then if this is 45 degrees, therefore this is 45 degrees, and this side it's going to be 1 unit long, this side is going to be 1 unit long, and this side to be root square root 2 unit long, right? And that's a hypotenuse side. And if also again you have a right angle triangle and the sum of the angles within a triangle, they equate to 180 degrees, and let's say this is 60 degrees, therefore there will be 30 degrees. Now if this is the case, this will be square root of 3, this is going to be 2, this is going to be 1. So these two triangles, you always have to remember them so that you can able to answer this question without the use of the calculator. This is going to be our calculator. And then what else you need to know? You need to know this fact here. So you have we call it a cast diagram, meaning in the first quadrile all trigonometric functions are positive. In a second quadrile, only sine is positive. In a third quadrile, only tan is positive. In the fourth quadrile, only cos is positive, right? I mean, when you're talking about the cast diagram, we're talking about that. So the first quadrile is between 0 and in 90 degrees. The second quadrile is between 90 and 180 degrees. The third quadrile is between 180 and 270 degrees. But I want to extend this. This can go as far as you can. I mean, you already can see that it's at a rate 90 90 degrees, right? Every quadrile is 90 degrees bigger, so that means this will be 270 plus 90 degrees, that's 360. This could be also 360 plus 90 degrees, that is 45 degrees. 450 degrees, 45 degrees, I mean 180. So 45 degrees plus 90 degrees, that is 540 degrees. I mean, you can already see the picture, right? That's basically the idea. And yeah, so even here you can just add 90 degrees, that will be 68. You can add another 90 degrees, that'll be 270, and so on. But we end here for the sake of this for the sake of this video. And one thing you need to know is you are always gonna be reducing your angles into your first quadrile, right? So if you see an angle, you wanna always have to reduce the angle to the first quadrant. That's the goal here. And if you have an angle that is on the second quadrant, you can just take 180 and minus that angle, and I'm going to show you. And then everything that is not sun is going to be negative, but if it's sun, it's going to be positive. I'm going to show you, don't worry, how you maneuver around that. Now if you in the third quadrant, you can just take that angle that is in the third quadrant and minus it with 180, and anything that is not tan, it is going to be negative. On the fourth quadrant, you can just take 360 minus that fourth and the angle that is in the fourth quadrant. Again, anything that is not cos is going to be negative. So one thing that you need to know here, what else that you need to know? Technically, these are the key notes that we need to know, and then I'll keep on adding some notes as well as we go forward. Okay, so firstly, so the idea here is you need to reduce your angle. So for example, the first question that you ask yourself when you see this, where is this angle? Where do I find this angle? Is it in the first quadrant? Is it in the second quadrant, third quadrant, or fourth quadrant? Yes, 110 degrees, it is between 90 and 180. So it is on the second quadrant, right? So now you've identified that 110 is on the second quadrant. Now the next question is this sign, positive or negative on the second quadrant? Sign is positive on the second quadrant. So this is what you write. Okay, so okay, sign is positive on the second quadrant and 180. Now what you're gonna do is you're gonna say 180 minus theta, and theta in our case is 110. So you're gonna just can write that down if you want to. 180 minus 110. So what we're doing is we're reducing the 110 into the first quadrant. That's what we are doing here. We're reducing the 110 into the first quadrant. Because if you say 180 minus 110, that's gonna be 70 degrees, and 70 degrees is on the first quadrant because it's between 0 and 90 degrees. Okay, so that's why with this one we cannot do anything. We can tan 60, we keep it the way it is. Why? Because 60 is on the first quadrant, so there's no need to reduce it. Do you get that? So if an angle is on the first quadrant, don't reduce it. So what do we do with that angle? You can already see it's 60 degrees, and we already have a calculator, our calculator. We can use it later, right? But on top of that, let me just add this. We need to know that sine theta is opposite over hypotenuse. Yes, that's correct. And tan theta is opposite over adjacent. That's correct. Cos theta is adjacent over hypotenuse. Okay, right. So we need to remember that, and we're gonna use it later on here. And then cos 540 again. Now this is where I wanted it to that's why I wanted to extend this all the way to here, because now we have 540. 540 is the same as 180. So cos 540 is equal to cos 180 in principle, because this is almost the same number. So am I saying 90 is equal to 450? Yes. Am I saying 0 is equal to 360? Yes. In principle, they're the same numbers when you talk about degrees. Okay, so we can rewrite cos 540 as cos 180 degrees. Okay, let me just dot. and then tan 250. Again, you ask yourself, where is 250? Is it in the first quadrant, second, third, or fourth quadrant? 250 is on the third quadrant. 250 is on the third quadrant. Now, is tan on the third quadrant positive or negative? Tan is positive on the third quadrant. So you write positive tan, right? And then it's gonna be now you're gonna say theta minus 180. Theta in this case is 250. So 250 degrees minus 180. And then you have sine 380. Sine 380. Again, where is 380? 308 is on the first quadrant because 308 is between 360 and 450. 308 is on the first quadrant. So if 308 is on the first quadrant, we need to reduce this. It's going to be 380. What do you think it's going to be? 380 minus 360. That's correct. Remember, we are trying to reduce an angle to the first quadrant. That is our aim. We're reducing an angle to fit on the first quadrant, right? 308 is equal to 80 degrees. 380 is equal to 20 degrees. But to see that, you can just say 380 minus 360. You can already see the pattern here. It was theta 180 minus that theta. Now it's theta minus 180. Okay, so now it's 360 minus theta. It was 180 minus theta. So what do you think the next one is? It's gonna be theta minus 360. Yes, right? The pattern continues like that. The pattern. So what do you think this is gonna be? It's gonna be, remember, so you're looking at 180 minus theta. So it's gonna be 540 minus theta. 540 minus theta. Therefore this is gonna be theta minus 540. So it goes on and on like that. So the pattern goes on and on like that, right? But the idea is, if you can't see it, what you need to remember is try to reduce that angle into the first quadrant. That's if you can minus something in your way in your mind that you can reduce it to the first quadrant, that's good. But you need to ask yourself, where is this angle that I'm reducing? It's on the first, second, third, or fifth quadrant. For example, this one is on the first quadrant. And is it sine positive or negative on the first quadrant? Sine is positive on the first quadrant. And then you're going to say that angle, which is theta minus 360, which is 380 minus 360. Okay. And then you have, so sine of 180 minus 110, that's 70 degrees. Now tan 60. Okay. Tan is opposite over adjacent. So tan is opposite over adjacent, and we're looking at 60. So you're looking at this triangle. So the opposite side of 60 is square root of 3. So this is going to be square root of 3. And then the adjacent side of 60 is 1. So it's going to be root 3 over 1, which is root 3. I can just write root 3 because root 3 over 1 is root 3. Now, what is cos 180? Cos 180. We can write how cos look like in a diagram. So if this is, let me just write this way, where a diagram, and cos looks like this in a diagram, right? Where this is 0 degrees, where this is 90 degrees. Can I just use a different color? Okay, so this is cos, where this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. That's cos. And then sine, you fundamentally look like this. This is sine. Okay. So we're looking at cos. That's what you're looking for, right? So when cos is 180, remember again, this is between 1 and -1, right? They all between 1 and -1. So when cos is 180, therefore your answer is -1. So cos of 180 is -1. So what I'm saying is cos of 0 is 1, cos of 90 is 0, cos of 180 is -1, cos of 270 is 0, cos of 360 is +1. So sine of 0 is 0, sine of 90 is +1, sine of 180 is -1, sine of 270, sine of 180 is 0, sine of 270 is -1, sine of 360 is 0. Okay, and then so cos of 180 is -1, so it's -1. Now tan, so you have tan 250 minus 180, that's 70, so tan 70 degrees. And then you have sine 380 minus 360. 380 minus 360 is 20, so you have sine 20 degrees. Okay. And then one thing that we need to also learn is this. If you have sine of 90 degrees minus theta, it's the same question, it's the same thing, the way of thinking. This is, I'll tell you now the answer. The answer, you know, this is cos theta. If it's sine 90 degrees plus theta, it is still cos theta. Why is that? It's the same of thinking. You don't even have to cram this. Sine of 90 minus theta. Where is 90 minus theta situated? Is it on the first, second, or third quadrant? 90 minus theta. It is on the first quadrant. It's 90 minus theta. So meaning it's 90 minus theta. It's less than 90 degrees. So it's on the first quadrant. So now, is sine negative or positive on the first quadrant? Sine is positive on the first quadrant. So you write positive. And then you change sine to cos to become cos. That's it. Then become cos theta. Again, 90 plus theta. Where is 90 plus theta? Is it in the first, second, or third quadrant? 90 plus theta is on the second quadrant. Is on the second quadrant, and sine is positive on the second quadrant. So you write positive, and then you change sine to cos, become positive cos theta. So now, can you tell me what is this then? Cos of 90 degrees minus theta. Cos of 90 degrees minus theta is, first you ask yourself, where is 90 minus theta? 90 minus theta is on the first quadrant. Is cos negative or positive on the first quadrant? Yes, cos is positive on the first quadrant. Then you write positive. Then, because it's cos, going to change sign to sine theta. Now you have cos 90 degrees plus theta. Again, cos 90 degrees plus theta. Now, 90 plus theta. Where is that? Is in the first, second, or third quadrant? It's on the second quadrant. Now, is cos negative or positive on the second quadrant? Yes, only sine is positive on the second quadrant. So cos is negative on the second quadrant. So you write negative, and then you change sign to be from cos to sine, so it's going to be negative sine theta. Voila. So you have to always just put in mind, that's how you answer these questions. That's how you maneuver around this question. If you have an angle and if sine or tan or cos, you ask yourself, where is this angle? Is sine or tan or cos positive in this quadrile? Yes, no. That's how you write it, and you reduce it to the first quadrile. That's what we're doing here. We just reduce it to the first quadrile. Theta is in the first quadrile. All right, so let's go. So so you have, technically you have sine. We can just write that sine 70 the way it is, degrees times root 3. You have minus tan 70 degrees times, we can change this sine 20 to pose to cos, right? You can change sine to cos. So sine 20 degrees, do you agree, is sine 20 degrees, do you agree? If you have sine 20 degrees and we're going to change it to cos, it's going to be cos minus 20 degrees, right? So it's going to be cos minus 90 minus 20 degrees. That is sine 20 degrees. That's basically what we are using here. Sine 20 degrees or sine theta is equal to cos minus theta. So sine 20 is equal to cos minus 20. And then this is going to be sine 70 times root 3 over negative tan 70 times cos 70, because 90 minus 20 is 70. And then let me wrap this off. It's fine, I don't mind repeating this. So we can just take sine of 70 degrees over cos, sine theta, sine, so we know this, sine theta over cos theta is equal to tan theta. So sine 70 over cos 70 is equal to tan 70. So this is going to be tan 70 degrees times root 3 over negative tan 70 degrees. There is negative tan 70 degrees. And then tan 70 over tan 70 is positive 1. So with tan 70 over negative tan 70 is negative 1. So you're going to have negative 1 times root 3. And negative 1 is just negative 1. So you don't have to write that down. So it's going to be negative root 3. Boom. That's your answer. 5.1.1. So that was long, but in a nutshell, I wanted it to go slow so you can get it. So let's go 5.1.2. 5.1.2. Okay. 5.1.2. So you have 1 minus root 2 sine 22.5 degrees, root 2 sine 22.5 degrees plus 1. Okay. So what you need to know here, firstly, you need to know this algebra. This is nothing to do with trigonometry. You need to know that if you have a minus b, b plus a, your answer will be a squared minus b squared. That you need to know. Okay, so this means that therefore this means that this is equal to 1 squared minus root 2 sine 22.5 degrees squared. That's basically what this means. So take me, this is our a, this is our b. This is a plus b minus b. It's going to be a minus b, a squared minus b squared. Okay, so 1 power 2 or 1 squared is 1, and we need to know as well this algebra that you have a b squared, this is gonna be a squared b squared, right? So Therefore, root 2 sine 22.5 degrees squared is equal to root 2 squared times sine 22.5 degrees squared. So this is 1 minus root 2 squared is 2 sine 22.5. I mean, we know, again, square root of 2 times, let's write a. Remember, a is just a number. A times a is equal to a, or root a squared, which is equal to a, because root a times root a is root a squared. Okay, so that's what we did with root 2. So root 2 squared is 2. Okay, right, so we're not done. So we have 1 minus, now this is squared, so we have 1 minus 2 sine 22. Now, one thing that you need to remember here is this. You have cos 2, let's say cos 2 theta. Cos 2 theta can be written as cos theta plus theta. And then you can use now compound angles. Compound angles says cos theta plus theta is equal to cos theta times cos theta. Likely you get this in your exam question, so you don't have to remember all of this, but you need to know the application of it, right? So cos 2 theta is equal to cos theta plus theta, and cos theta plus theta can be written according to compound angles, can be written as cos theta times cos theta minus, instead of plus, it's going to be minus now, sine theta. This is going to be cos squared theta minus sine squared theta. And we know sine squared theta plus cos squared theta is equal to 1. Therefore, sine squared theta is equal to 1 minus cos squared theta. And cos squared theta is equal to 1 minus sine squared theta. So we can apply that here and say cos squared theta is equal to 1 minus sine squared theta minus sine squared theta. So this is 1 minus sine squared theta minus sine squared theta is 2 sine squared theta. Right, so that's one solution. I mean, that's one solution. That's the second solution, right? And again, from the first solution, we can write cos squared theta and transform that negative sign to cos. So it's going to be 1 minus cos squared theta. So cos squared theta, 1 minus and minus become positive. So cos squared theta plus cos squared theta is 2 cos squared theta minus 1. So this is another third equation. So what I'm saying is, I just proved to you how these formulas that you know, sorry about that, these formulas that you know, that cos 2 theta is equal to cos squared theta minus sine squared theta, and could be written as 1 minus 2 sine squared theta, or could be written as 2 cos squared theta minus 1. And you can do the similar exercise with sine 2 theta. Sine 2 theta is equal to, according to compound angles, could be written as sine theta plus theta, which is sine theta. Instead of sine theta times sine theta, now it's going to be sine theta cos theta plus, it's no longer negative, it's going to be plus, again, cos theta sine theta. Now, this is the same thing. Sine theta cos theta plus cos theta sine theta is the same thing. It's 2 plus. This is 2 plus sine theta cos theta. So 2 sine theta is equal to 2 plus cos theta sine theta. We're just proving this using compound angles. Right. So we see this. This is 1 minus 2. This is 1 minus 2 sine squared theta, and it looks like that, 1 minus 2 sine squared theta. So your answer is cos 2 theta. Remember, theta here is 22.5. So our answer is cos 2 times 22.5 degrees. And 2 times 22.5 degrees, what is that? 2 times 22.5 degrees is 45. So you have cos 45 degrees. And what is cos 45 degrees? Cos 45 degrees, again, I said I don't mind repeating this. So I'm going to... So we said we have our calculator. For 90 degrees and 45 degrees, 45 degrees. Sum of the angles within your triangles equal to 1. So this is going to be 1, it's going to be 1, it's going to be square root of 2. So cos 45 is, remember, cos is adjacent, cos is opposite of adjacent. So cos 45 is opposite. So whether you look at this 45 or look at this 45 doesn't matter. Let's look at this 45. The opposite side of 45 is 1. The adjacent side of 45 is 1. So cos is gonna be 1 over 1. Opposite over adjacent, and this is just 1. You can just write 1. So cos 45 is 1. But I did a mistake. This is a mistake. Please, this is a mistake. This is a mistake. You need to always remember. I'm sure some of you guys have seen it. If you haven't seen it, please pause this video and check the mistake. I just did a mistake. But if you have seen a mistake, well done. Please pause this video if you haven't seen the mistake and check the mistake. Okay, this is the mistake. The mistake is I said cos theta. Cos is equal to opposite of adjacent. This is not right. This is not right. My goodness, this is not right. This is not right. What is right is cos, we can just write theta. Cos theta is opposite over no, not opposite. It's adjacent over hypotenuse. That was cos theta is. Cos theta is adjacent over hypotenuse. Sin theta is opposite over hypotenuse. That's sine. Tan theta is opposite over adjacent. Nah, this is correct. Please don't forget that. Don't forget that the way I just did. Right. So cos theta. Now the question is how do you know that you get the wrong answer? You can always punch this in. Of course, they tell you don't use the calculator. They tell you that, but you have the calculator in your hands. You always have to punch this in your calculator and see if you're getting the same answer. Just to see if you're getting the same answer, not to use the calculator. You're just seeing if you're getting the same answer that you are calculating. That's basically how you would use your calculator here. So you can literally punch in your calculator cos 45. Do you get 1? No, you're not getting 1. You're getting something like square root of 2 over 2. So there's something wrong. And that's how you figure it out. Okay? Boom. Now, cos 45. Cos 45. Cos 45. So cos is adjacent over hypotenuse. So it doesn't matter what you're using. Let's just use that. What is the adjacent side of 45? Is 1. So it's going to be 1 over, now the hypotenuse is root 2. So 1 over root 2. So that's cos 45 is 1 over root 2. And one may say, but it's 1 over root 2 is not the same as what I got in your calculator. Root 2 over 2. Take in your calculator and punch 1 over root 2. And see what you get. Do you get root 2 over 2? It's the same. So 1 over root 2 is actually the same as root 2 over 2. How is that the same? If you're curious, just if you're curious, let me show you. If you're not, it's fine. I'm going to show you anyway. So this can be written as 1 over root 2. You can multiply it by 1, right? Root 2 over root 2 is 1. So you can just multiply it by that. Because you're not necessarily doing anything. Root 2 over root 2 is 1. So 1 over root 2 times 1 is 1. Is 1 over root 2. So you're not doing anything. And then 1, now you're multiplying these two fractions. So 1 times root 2 is root 2. And root 2 times root 2 is 2. That's how 1 over root 2 is equal to root 2 over 2. So, and this is how the lectures or the teachers will figure out that you used the calculator or you didn't use the calculator. Because if you use the calculator, this is what you're going to get. But if you do not use the calculator, this is what you're going to get. Tricky, I know. Anyways, so let's go 5.2, 5.2, 5.2, 5.2, 5.2. Okay, so you're told something like given expression cos 2x times tan x sine squared x. 5.2.1, for which values of x in the interval x between 0 and 180 would the expression be undefined? Okay, now breathe. Okay, I know it's hard English, but it's not hard. Okay, think about this as a fraction. Okay, a over b. If you have a over b, when is this be undefined? Undefined means you're getting math error. That's what undefined means in your calculator. When will you, in a fraction, get a math error? Let's say you have a fraction. Imagine a fraction. A over b. How will your b look like for you to get an error here? So for me to get an error here, my b should be equal to 0. So if I have a over 0, I'll get what? The math error. Doesn't matter what a is, which is undefined, not applicable. Doesn't matter what a is. A can be, well, I don't know, 1000 divided by 0. It is going to be math error, undefined. So this equation, it is going to be undefined if the denominator is equal to 0. Okay, so again, so this is going to be undefined if sine squared theta, not theta, not x, is equal to 0. Now you have a simplest. It's not as simple, but you have it. You have an equation that you can use. Now you have sine squared x is equal to 0. Then we can now solve for x. Now, how do you solve for x in a situation like this? If you have sine squared theta is equal to a, then you can just say sine theta is equal to can you just square the square root of a? Okay, just to remove this this part 2 there, and then theta is equal to sine inverse of a square root of a. I mean, even with tan theta, it's still the same thing. Let's call it b. Theta is equal to tan inverse of b. Even cos as well, cos inverse of b. Okay, so that's what you're going to be doing here. So sine squared theta, so that's what you're doing. Find the square root of 0. What is the square root of 0? Feel free to punch this in calculator if you don't know. What is the square root of 0? Okay. What is the square root of 0? Square root of 0 is 0. So you have sine x is equal to 0. Now, solving for x, so it's going to be x is equal to sine inverse of 0. Alright, so what you need to do from here, right? Because they say the interval of x, for which value or values of x, English, for which value or values of x in the interval 0 to 180 will this expression be undefined? Okay, now define what it means by undefined in a fraction. Now you need to understand values, so they don't ask you a value, right? Because if you punch in a calculator, sine inverse of 0 is 0, right? If you don't know how to punch your sine inverse into 0, just shift and then sine. Shift, sine, shift, sine. That's how you punch your sine inverse. Shift, sine. So sine inverse of 0 is 0. But it's a value. But there are values that you can get. So this is a trigonometric equation. Okay. This is a trigonometric equation. Trigonometric equation. Okay. Trigonometric equation. Let me just type equity and equation. Trigonometric equation. So trigonometric equation says if we have sine theta is equal to m, then okay, if theta sine theta is equal to m, then theta is equal to your reference angle, we call it RA, reference angle, plus 360 degrees times K. K is positive integers, or just integers, where K is integers. Or theta is equal to 180 degrees minus a reference angle plus 360 degrees times K. Again, K, these are positive integers. Positive integers meaning 1, 2, 3. Oh, it's not positive integers, it's just integers. In this case, positive integers. Just gonna stick in positive integers. Let me write positive. Positive integers. Integers just 1, 2, 3, 4, 5. Just those numbers, right? There's our integers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Those are integers, okay? Okay, this is the equation that we're gonna use, right? But I mean, just because you're learning, revising, you have cos. If cos theta is equal to m, then theta is equal to plus or minus RA, reference angle, plus 360 degrees times K. What is a reference angle? Okay, maybe that's a pending question. Somebody's asking, what is a reference angle, Percy? A reference angle, this, how can I put this? Reference angle. What is a reference angle, Percy? A reference angle, the angle that you're gonna get by saying, punching in your calculator, sine inverse of 0 is equal to 0. This is not your x, this is your reference angle. Make sense? This is not your x, this is your RA, this is your reference angle. So when you punch in your calculator and say sine inverse of 30 degrees, that is not your x, that's your reference angle. So sine inverse of 0 is a reference angle in our case. So your RA in this case is sine inverse of 0, which is sine inverse of 0. You can punch your calculators 1, 2. Sine inverse of 0 is 0 degrees. So that is our reference angle. Okay. So we say if cos theta is equal to m, then theta is equal to plus or minus RA. Now you see it's different. Now if it's tan theta is equal to m, then theta is equal to a reference angle plus 180 now. Cos that is a positive integer. So it varies, it differs, blah blah blah. Okay, so you pick your equation. So if they are talking about sine, this is the 2 equation that you're gonna use. They talk about cos, this is 1 equation you're gonna use. If they talk about tan, this is another equation you're gonna use. So in this case, what do they talk about? They talk about sine. So it's sine x is equal to 0. Our m is 0. Right? And then you just find the RA. RA is 0 degrees. So you're gonna use this angle, this equation, and this equation. So meaning that then x is equal to RA, which is 0 degrees, plus 360 degrees times K. k it's an element of a z integer. So technically then x is equal to 360 degrees times k, or x is the first angle, so we just use this first equation, or we can use the second equation. X is equal to 180 degrees minus RA, which is 0, plus 360 degrees times k. K again. So you can say 180 minus 0. We don't have to punch that in a calculator. We know. What is 180 minus 0? We know that. Right? You are. 0, right? 180 minus 0 is 0. So this is the two equation. Now they're saying now we were looking for the x values. This is a very loaded question. They're looking for the x values that are between 0 and 180. There's a quicker way of doing this. I'm not going to show you that one because I want you to learn. I'm answering other questions that this fellow student of mine didn't ask. So I'm answering all the trigonometric questions at once. Right. Because I want to teach you. I want to teach you what is trigonometric equation. I want to show you that to you. Let's go. All right. Then you have x is equal to 360 times k, or x is equal to 180 plus 360 times k. Right. So how are we doing this? Let's answer the question for which values of x? Which values of x? For which values of x? 360 times k, or x is equal to 180 times plus 360 times k. Okay. So these x values, they should be between 0 and 180 degrees. They should be between 0 and 180 degrees. So you can now take your calculator and type it and rather create a table like this and say, okay, let's take k. K can be let's not make it a positive number, let's make it a negative number, because I want to show you how these z integers would look like. So let's take it like, can take any negative number, like maybe -5, -2, -3, and go down to 0 and start building up to 1, 2, 3, 4, 5, right? Let's take any of those numbers. I mean, we can take -1 if you want to. Start at -1, 0, 1. Yeah, it really doesn't matter which number we take. Let's take these two numbers. Okay, now if can take -2. It's just that in my mind I see why I should take -1, but let's take -2 just for argument's sake. Okay, so if k is -2 in the first equation, what do you get? So you have 2 x's. What do you get? First equation, you get, so 360 times -2, you get -720. Is -720 between 0 and 180? No, so we're not going to take this one. If k is -1, what do you get? -360. -360. Is -360 between 0 and 180? Nope. So we're not going to take this one. Now, when k is 0, what do you get? 0. Oh, okay. Is 0 between 0 and 180 degrees? Yes, 0 is between 0 and 180 degrees, so we're going to take this one. Alright, so we have a x value and x value. Now, let's go to 1. 360 is 360 times 1 is 360, so this is not between, I don't have to go there, but you see that what I'm going. 360 times 2, 720. 720 is not between 0 and 180. Now, let's go to the second equation, because we're looking at the first equation. Now let's go to the second equation. So we can say 180 plus 360 times -2. Okay, is -540 between 0 and 180? No. So you're not going to take that one, negative 540. So you're not going to take that one, negative 540. Now let's take negative 1, negative 180. Is negative 180 between 0 and 180? No, it's negative 180, so it's not. Alright, okay, going somewhere. 0. Is 0 between 0 and 180? Sorry, this is if we put 0, it's going to be 180. So it's 180 between 0 and 180. Yes, so we're taking this and that. Oh, nice. Now let's put 1. Is 540 between? No. Is put 2. Is 900 between? No, it's not. So our answers are 0 and 180. 0 and 180. Those are the answers. 0 and 180. So x is equal to 0 and 180 degrees. So x is equal to 0 degrees, or x is equal to 180 degrees. Alright, so that's basically how you will actually do these calculations. If you got questions, please comment. Please comment, and I'll definitely attend to your question. So let's go 5.2.2. Blah 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 blah. Boop boop boop. Wait. Boop 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 boop. What? Boop 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 boop. 5.2. It's not. When my that died in. 5.2.2. Limit this. 5.2.2. Prove that cos 2x times tan x. I used to love this. Is equal to cos x over sine x. It's like my favorites in trigonometry, because you know the answer. So here, trying to prove that the right hand side is equal to the left hand side. That's basically the proof, right? So let's take the left hand side. Cos 2x times tan x over sine squared x. So let's prove that it's true. I mean, we already know, we talk about this. 2x could be written as cos squared x minus sine squared x, or 1 minus 2 sine squared x, or 2 cos squared x minus 1. So we can simplify cos 2x, and maybe just use this one. If you want to, we can use this one. Cos 2x is equal to 2 cos squared x minus 1 times, we know tan x. We don't have to simplify that one. Why? Because we have tan x there, so let's keep tan x the way it is. So let's just say times tan x divided by sine squared x. So the reason why we pick this one, cos squared x, is because in our solution you have cos and sine, so it really makes sense to pick this one. It makes sense to pick the one with the cos, so you can have cos and sine. So we're going in the right direction, right? And then so from here you have 2. You can multiply. I don't know if you want to see this actually. Okay, so the way I would do this, so you would just say, okay, let's divide this first and divide that and times with that. So what I'm saying is, this is the same as 2 cos squared x over sine squared x minus 1 over sine squared x times tan x, right? We know this. We know a over, let me write it blue. A or minus b over c is a over c minus b over c. That's what I did there. So this is a, this is b, and this is c. Okay. And then this is gonna be let's keep it this way. So you have 2 cos squared. Now we can multiply. We can multiply by tan both sides. So you're gonna have this times that, this times that. So you're gonna have 2 cos squared x over sine squared x times tan x minus tan x over sine squared x. Right. Alright, and then let me wrap this. So still looking at the left hand side. So the left hand side is equal to 2. I mean, tan x we know is sine x over cos x, so because cos squared x sine squared x times sine x over cos x. That's tan x minus, even with this one is I'm reluctant to write this actually, but you have tan. Let's write it. So let's keep it that way. So you have sine x over cos x, right, divided by sine squared x. That's basically what I'm doing here. Tan x is sine x over cos x divided by sine squared x. Okay, and then so this is sine squared and sine x cancel, so we left with sine x. Cos squared and cos cancel, we left with cos. So you're gonna be 2 cos squared over cos is cos x. Sine x over sine squared x is sine x. Okay, we're left with that. So at least we have light. So we have cos over sine, so we have that. Okay, we're going somewhere, we're going somewhere, we're going somewhere. Minus, now again, sine x, this division. Let's deal with that. How do we deal with that? This could be written as sine x over, let me write this note for you. A over B divided by C could be written as A over B times 1 over C, a reciprocal. So if you have a division sign, you can just change to multiplication sign, but this has to change to be 1 over C to be a reciprocal of that. So even if you have like A over B over D like this, so it was gonna be D over C if you introduce a division sign. Okay, so then you can now say A times 1, which is A, B times B, which is BC. So your answer would be A over BC. So that's what you're going to be doing here. So you have sine x over cos x times 1 over sine squared x. Right. Then we have 2 cos x over sine x minus sine x times 1 is, we don't have to do that. Sine x and sine squared x is sine x and sine squared x is sine x. Why are we not getting the answer? Prove that this is true. Yeah, you know what, I'm not gonna cut this because I wanted to make it raw. Do you see that we're not getting the answer? We're not getting the tan x. We're not getting tan x. So you have sine x, sine x over sine squared x is sine x. So you have 1 over cos x sine x. Okay. Now we have that. That's the only right thing. There's a 2, there's this. Now how do we deal with this? Okay. This is my submission to you. Please, because I want to increase engagement to this video, and I know who came up to, who waited and stay with me to the last part. I want you to go and do this part and continue from here. and tell me how you got this answer. Or if you have a different approach, please share. Please share that different approach and show us how you got to that different approach. Please. If you have a different approach, please share. Tell us how you got to that different approach. And then later on, if I got a lot of engagement on this part, and then I'll show you guys how to answer this question. All right, let's go. This was awesome. It's the longest video, but again, thank you so much to one of my students and the group AskPercy. You also can join AskPercy. Go to AskPercy. Go download Telegram if you don't have it, or if you have Telegram, just go to Telegram and search AskPercy. You search AskPercy, you're gonna see the group and join the group, right? So there are two groups, by the way. There's a group where you get it a free version of the group. So there are two groups. Let me explain. There's a public group and there's a private group. You're gonna get an AskPercy, which is a public group that you can join. You post the question. That group is free, right? But the catch here is I'm gonna record the video and post it on the YouTube channel. I'm not gonna post it on the group. I'm gonna share a link with you on the group that directs you to the YouTube channel. So I want you to watch it from the YouTube channel so that you can have a community that is sustainable. Because sharing these videos for free on the group is not a sustainable model, right? So you can have a sustainable community, then we need to that's why I'm sharing them on the YouTube channel so that you can support me as well and watch from the YouTube channel, as I am supporting you with these questions that you need help with. But if you don't have enough data and you want an immediate response, because with this free group that you're going to be joining, AskPercy, I'm not going to respond as quick as the other group. The other group is a subscription group, so you pay monthly, just 100 rand, and you can ask as many questions as you can, just 100 rand. And I'll create a video that help you answer those questions as soon as quickly, right? I'm create a video as soon as you post. I create a video to show you how to answer that question, just to help you with maths. But then with this one, I'll post it on the group and I'll post it on the YouTube channel. So it's up to you. If you want to stick with the free version, it's fine. Please, you're gonna be watching it on the YouTube channel. But if you wanna pay 100 rand a month subscription and you want quick fast, please join the monthly subscription group. It's just 100 rand. It's, and I could have done this for free, and I've done it for like 6 months for free. And the reason why I'm doing this way is because I want to build a sustainable community. I don't want to build a community that will fail in the wrong line. I want to build a community that will last forever. That will last forever.